So, in the last lecture, I left some important points about shortest job first algorithm. So, I'm going to tell you all those points now. So, you see, shortest job first algorithm is practically not possible. So, why? Because here you see this algorithm, it totally depends upon the burst time. The process with lower burst time will be selected first. Okay, that's why. So here you see it's difficult to predict. Just before the execution of the process, it's difficult to predict whether it's difficult to predict the burst time of the process. So before the process has started its execution, how will you predict? So that's the main problem with this algorithm. It's a hypothetical concept, but it's not a practical one. Okay. Several algorithms have been proposed to solve this problem to predict the burst time, but I will tell you about that after SRTF algorithm. And the another important thing is that I forgot to tell you that SJF algorithm is both non preemptive and preemptive. Don't worry, I will tell you. So till now, the version of SJF algorithm that I have taught you is non-preemptive algorithm. Okay. So actually, its preemptive version is called SRTF. That I will tell you in the next lecture. The preemptive version of shortest job first algorithm is known as SRTF, and its non-preemptive version is called SJF. And SJF I have taught you. Okay, this thing is left. So, but in examinations, sometimes the questions comes like this. They ask you to apply SJF concept with preemptive scheduling. Okay, SJF concept with preemptive scheduling. So, in order to solve that question, you should apply SRTF algorithm. I will tell you about SRTF algorithm. Okay, so you have to read the question very carefully. If they are asking you to implement SJF algorithm, and moreover, if also they have mentioned one point that the preemptive that the algorithm should be preemptive, then simply understand that it's SRTF algorithm. Okay, and if nothing is mentioned, just simply written SJF, then just apply non-preemptive version that I have taught you. Okay, and also one thing is that in the last class I told you that SJF algorithm, so there is starvation in SJF algorithm for longer jobs, but I think I didn't explain you properly, but in this video I will explain you. You just watch it. So just note this point. Okay. Now I will explain you how starvation happens for longer jobs in SJF algorithm. You see, so just think there are several processes. Okay. So with the help of this example, it will be very clear to you. Arrival time is given, burst time is given. So the processes are P0, P1, P2, P3 and P4. Okay. And let the arrival time of P0 is 0 and its burst time may be of 5 seconds. Okay. Then now come arrival time P1. Its burst time is 2 seconds. Now P2 came. Its burst time is suppose 3 seconds. Then Then P2 came. Its burst time is suppose 7 seconds. Okay. Then P3 came. P3 is, just wait. Then P3 came. So P3's arrival time is, say, 4 seconds, and its burst time is just 1 second. Okay, so no need for P4, it's enough. So now you see how starvation will happen here. Okay, just wait. How starvation will happen here? Just listen very carefully. So according to shortest job first algorithm, you see what will happen. Let's draw the Gantt chart. You see, at time 0 seconds, only process P0 has arrived in the ready queue. None of the process except P0, only P0 has arrived. So here I will write P0. Okay, and since it's a non-preemptive version of SJF algorithm, so P0 will execute till 5 seconds. Okay, there will be no preemption. If you have any doubt regarding this point, then just watch my previous video. Okay, so up to 5 seconds P0 will run successfully and the task of P0 is done. Okay, so no need to write because it's already a non-preemptive SJF. Okay, now you see within these 5 seconds, how many processes are available? See, P1 came at first second, P1 came at first second, P2 came at second, and P3 came at third second. Okay, we have 3 processes available. By the time P0 gets finished, we already have 3 processes available. So since it's a shortest job first algorithm, so we will select which process. Definitely we will select the process with lower burst time. We will select P3. Okay, so here P3 will come. P1 will not come. Here P3 will come. If it would have been FCFS algorithm, then definitely P1 would have come. But since it's SJF, so we are selecting the process with lower burst time. So P3 will come and P3 will execute for 1 second. Since its burst time is 1. So P3 is done. Okay, and P3, the task of P0 and P3 is already completed. So how many processes are left? P1 and P2. And now you see, definitely we will select P1 because P1 has lower burst time than P2. So here I will write P1 and here it will run for 2 seconds, mean 8, and P2, and after that P2 will come. So here I will write P2 and its burst time is 7 seconds. So 8 plus 7, 15. So with the help of this Gantt chart, you just see by the time P0 finished, all the processes P1, P2, P3 arrived, but we selected P3. After that, we selected P1. After that, we selected P2. Although P2 came earlier than P3, but P2 executed at the last. Why? Because P2 has the longer burst time. It means what? Here, the processes with the longer burst time has to wait more, maybe till the end, just like in this case. P2 waited till the end. Okay, and also you see when P1 came at 1 second, but since its burst time was greater than P3, okay, but so that's why CPU was not allocated to P1 after P0. CPU was allocated to P3. Okay, so P1 waited till the execution of P3. So here you see starvation is happening for the longer jobs, and with the help of waiting time it will be more clear to you. You see, let's calculate the waiting time. Here I am not using the formula of waiting time. I am simply using the concept. You see, P0 arrived at 0 and got immediately scheduled at 0. So P0 will not wait. Okay. After that, you see P1 arrived at 1 but got scheduled at 6. So what's the waiting time of P1? 6 minus 1, 5. And you see P2 arrived at 2 but got scheduled at 8. So P2 waited the most. So what's the wait time of P2? 8 minus 2, 6. And similarly, P3 arrived at 4 and P3 got scheduled at 5. So what's the wait time of P3? 5 minus 4, 1. So here you can see that the process, although P2 arrived before P3, but P2 waited longer than P3. Why? Because P2 has the largest burst time. Also, you can see P1 arrived before P3. Also, P1 waited longer than P3. Why? Because P1 had larger burst time than P3. Okay. So it's a very small example, but I think it's enough to make you understand that SJF algorithm, how starvation for longer jobs happens in SJF algorithm. So you just remember this point. At starvation for longer jobs may occur in SJF algorithm. Okay. So it's a non-preemptive version. Okay. So in the next lecture, I will teach you about the preemptive version of SJF algorithm, which is also known as SRTF, shortest remaining time first algorithm. So there we will see that is it possible to get rid of this problem or not. Okay, there we will see.